Hello and welcome to Electricity Lesson 3. Today we're going to be looking at series circuits. We'll just have a quick recap of last lesson. So last lesson we looked at the relationship between current, potential difference and resistance. Now I quite like this picture here because this nicely illustrates what we mean by these quantities. Okay, potential difference is measured in volts, and that's the push that is making the electricity flow. What is flowing? Well, it's charge. In metals, it's electrons, and that has the unit of amps. So the current is the thing that's moving. And what is trying to stop the current flowing? Well, that's the resistance. Resistance measured in ohms is trying to stop the current flowing. And we looked at the equation that relates these three quantities last lesson, and we said that resistance is potential difference divided by current. This is probably the number one most important equation in all of electricity, and something you definitely need to remember. And there's a quick summary of the main quantities that we've looked at, the symbols and the units. I'll give you a couple of seconds just to remind yourself of everything in this table. So today we're going to look at series circuits. So what do we mean by series circuits? Well, series means a line or a sequence. It means when you put everything in a row. So here is a series circuit. We've got a battery, or actually a cell, and there is one root. There's a resistor, there's a second resistor, and then it goes back to the cell. There is one root and only one root, and all of the things are in a line or in a row or in series. So this is called a series circuit. Here is what I've just been saying summarized for you to make a note. Now, we're going to look at many different types of circuits. You might notice that sometimes they're in parallel, and we'll talk more about that next lesson. You might notice there's a combination of series and parallel. And that happens all the time. All right. But whenever there's two components next to each other in a row like this, they are in series. So, quick quiz. Series or parallel? There is only one root round. There are no branches. This must be series. Here, let's have a look. We go this way round, and actually there's two possible branches here. So this is not series. This is what we call a parallel circuit. This is a parallel circuit because of the voltmeter here. If we ignore the voltmeter, then everything else is in series. This is series. And this one here is series. So let's have a look at the current in a series circuit. So what happens to the current? Well, there's only one route round for electricity to flow. So remember that it's the electrons or charges that are flowing around a circuit, and we usually say they go positive to negative. This one here is the positive and the short one is a negative. So if there's only one route round, where can the electrons go? Well, they don't disappear. They don't get used up. They're always there, moving round and round and round. So if we measure the current here as 0.7 amps, what's the current going to be here? It's also going to be 0.7 amps. What's the current going to be here? Well, again, the electrons haven't disappeared. They haven't gone off anywhere. So it must still be 0.7 amps. What would happen if I had a circuit such as this with one bulb and an ammeter, and I measured the current here or measured the current here? Are they going to be the same or different? Well, they're obviously going to be the same because the current is the same everywhere in a series circuit, in a circuit where there is only one path round. Now, how do we measure it? I've shown you this symbol here, which you should know is an ammeter. What's really important for you to remember, ammeters are always put in series, and they have a very, very low resistance. We don't want the ammeter to affect the current, to change the current. So they have a very low resistance. I'm going to summarize these notes for you on the screen now. All right, now we're going to look at resistance in series. So here we've got a short section of a circuit. So obviously this is not a complete circuit, so it's not going to work as such, but I've just taken like a small section to simplify it. We've got 3 resistors here. What's the total resistance going to be? Well, imagine you're trying to get through the first one, but then you have to get through the second one and the third one. It's obviously going to be harder. So therefore the resistance is increasing as we move through things in series. How do we work it out? We simply add them together. So we do 10 plus 20 plus 15, and that will obviously give us our answer of 45 ohms. 3 very quick examples for you to try. Pause the video now and do these examples. Fairly easy. We just add them up and we get 59 ohms for number 1, 238, and 13 ohms for number 3. Okay, finally, we're going to look at potential difference in series. So what happens to the potential difference in a series circuit? So if we have a bulb, 2 bulbs in a circuit and a battery, what will change if we have 3 bulbs in a series circuit with the same battery? Well, if this battery was, say, 3 volts, that's 3 volts of energy per electron. As the electron goes around, how is it going to transfer its energy to the bulbs? Well, the first bulb is going to get some of the energy, the second bulb is going to get some of the energy. What about if it's the same battery but 3 bulbs? Well, now that electron has to give some of its energy to the first one, some of its energy to the second one, some of its energy to the third one, and it's sharing its energy a lot more. If there was just 1 bulb, there would only be 1 thing for it to give its energy to. So if this had 3 volts of energy, how much is this one going to get? Get 1.5. How much would this one get? 1.5. What about the right-hand circuit? If this had 3 volts of energy, then this is going to get 1, this is going to get 1, and this is going to get 1 volt of energy. What also will happen is because that energy is being shared out between more components, the bulbs are going to get dimmer on the right-hand side. So each bulb gets less energy, and if something gets less energy, you can probably realize it's going to be less bright. So a couple of quick questions. What voltage or what potential difference will be across each bulb? Obviously here, this gets 1.5, this gets 1.5, and this gets 1.5. Hopefully you found it super easy. Each bulb gets 2 volts. And finally, each bulb gets 120 volts. You've probably noticed that the voltmeter here, the measuring instrument for measuring potential difference, is always in parallel. Here are a short section of notes on voltmeters for you to make. So here is a summary of everything that we've just talked about. Current is always the same in a series circuit. Potential difference is shared between components in a series circuit. Resistance increases when components are in series. You add up the individual resistances. A higher resistance means a lower current. Current is measured with an ammeter in series. Potential difference is measured with a voltmeter in parallel. So let's have a quick look at this in our circuit simulator. So I've built 2 circuits here. The top circuit has 1 battery, 1 bulb. The bottom circuit has 1 battery and 3 bulbs. Immediately you can see the top circuit has a higher current. There's more electrons passing a point in 1 second because there's obviously less resistance in the top circuit. Let's have a look at the current and see if everything I've said is true. So let's measure the current here. You can see it's 0.9 amps. If I measure it at the bottom, what will it be? It will also be the same. If I measure it after the bulb, will it be the same, more or less? It's exactly the same. And I'll measure it in one more place, and you can see it's exactly the same. What about the bottom circuit? Is the current going to be more or less than 0.9 amps? Obviously going to be less. And I will show you it's going to be the same everywhere in the circuit because it's a series circuit and there is only one path around. Let's have a look at the voltage or the potential difference. So let's check what the voltage of the battery is. It's 20 volts. So what's going to be the voltage across the bulb at the bottom? Well, there's only one bulb, so it must be 20 volts as well. Let's compare that to the second circuit. 20 volts for the first, 20 volts across the battery. What's the first bulb going to be? Well, there's 3 bulbs, each will get a third, so that's one gets 6.67. The middle one, 6.67, and the final one, 6.67. What if I measure 2 at the same time? Well, the potential difference from here to here is going to be twice that, so it's going to be 13.33. If I measure the potential difference of all 3, you guessed it, 20 volts. So again, I'll provide a link to this simulator and you can build your own circuits, you can build some series and parallel circuits, and you can test out these ideas for yourself. Got one more thing to do. Some slight, well, actually they're not harder at all, but some two-step calculations. How would you calculate the current in this circuit? Well, what do we know? We know what the voltage, the potential difference is. We can work out what the total resistance is. 2 plus 4 is 6. What equation links current, potential difference, and resistance? We know that resistance is potential difference divided by current, so we can work out what the current is. So step 1, what's the total resistance? Step 2, write down our equation. Step 3, put in numbers. Step 4, get the answer and all the marks. Okay, there's nothing hard about this question. It's basically just using one equation with a tiny little extra step first. So there's 4 questions for you to do. So you can pause the video now, do these questions. In each of these examples, you always do the total resistance first. So step 1 will be work out 5 plus 10 is 15. Step 2, you write down the equation. So current is potential difference divided by resistance. Step 3, put in the numbers and get the answers. Here are all of the answers. So now we are at the end of the video. I will set you some questions on everything you've learnt in today's lesson, as well as summarize the information for you in a document. Thank you. Goodbye.